Early in the course, we created a smart pointer class that takes an integer pointer in its constructor and releases it in the destructor, similar to smart pointers in the standard library. But with our current implementation, we cannot access the actual integer that this pointer points to. So here we have an integer pointer, but there is no way to access that underlying integer in memory. So we cannot read or modify it. To solve this problem, we need to overload the indirection operator. So here we add a new operator, indirection, without any parameters, and the return type has to be integer as a reference, because we'll be accessing an existing integer in memory, okay? Now, in reality, you never have to overload this operator because we have smart pointers in the standard library that work perfectly fine. So there is really no need to overload this operator. But again, doing this as an exercise is a great way for you to better understand and appreciate how the standard library is built. So let's go ahead and generate the definition. Good. Now, just like always, I'm going to move the ampersand right to the type. Now, what should we return here? Well, in this class, we have an integer pointer called ptr. So we can take that and dereference it to access the underlying integer. As simple as that. Now we can go to our main file. On the top, we include the smart pointer header file. Now here we create a smart pointer called ptr, and we initialize it with a new integer pointer. So we are allocating memory dynamically on the heap or the free store, and this pointer object will take care of deallocating memory. So when the main function finishes execution, this object will go out of scope, its destructor will get called, and that's where the memory gets released. Now here we can dereference this pointer just like raw pointers in C++ and assign it a value like 100. Now to verify that this works, we can print ptr. Now let's change it one more time to 101 and print it one last time. Now it's better to add endl here so we can see things clearly. Now take a look. There you go. So this verifies that our indirection operator was properly implemented.